Hey everyone! In this video, we are going to be using a beginner kinematic equation, v equals d over t, but we're going to introduce some uniform acceleration. Ha ha ha, you say you can't have acceleration with this equation. Let's find out. So we have a skidoo, and it's traveling 15 meters per second over a period of 6 seconds, and it experiences uniform acceleration. And again, you're like, you can't do a uniform acceleration. It's v equals d over t, and it goes until it comes to rest, 0 meters per second. Okay, then we go velocity final. How far did it travel? I am going to be using the equation v equals d over t. Oh, but we got two velocities. What's supposed to happen here? Here's the thing. A lot of people, when they learn how to use this equation, they do remember that that velocity is a constant velocity, and that seems to get like ingrained in our hearts. But there is a second option. When you're using v equals d over t, that v value can also be an average velocity. It could be an average velocity. And if we have uniform acceleration, if we have uniform acceleration, we can solve that average velocity using the following equation. The velocity average will equal our velocity initial, and we're going to add that to our velocity final, and divide by 2. And this will actually give us a usable velocity. So our velocity average is going to equal our initial velocity, which was 15. And we're going to add that to our velocity final. It was at rest. That's 0. And we're going to divide that all by 2. What we're going to end up with is an average velocity of 7.5 meters per second. Now we have v. Now we have v. This question, it becomes no different than if we had just told you a skidoo was traveling 7.5 meters per second for 6 seconds. So we fill in the 7.5 for our velocity. It equals d for our displacement over our t, which is 6 seconds. We multiply that t up to the other side, and it leaves us with d equals 139 meters. And just like that, we can use the equation v equals d over t even when a question has an acceleration. We're going to take a look at one more example here because I want everyone to see how we can really apply this average velocity idea. A car goes from 20 kilometers per hour, I will underline, to 80 kilometers per hour. And it's experiencing uniform acceleration. That means the acceleration is the same the whole time. That's a flag over a period of 10 seconds. How far did the car travel in that time interval? Most times when we're dealing with acceleration seconds, convert those kilometers per hour to meters per second. And the conversion for that is dividing by 3.6. Now, 20 divided by 3.6 is 5.56 meters per second, about-ish, good enough for us. And the 80 kilometers an hour divided by the 3.6 will equal 22.22 meters per second. Okay, now we've got them in meters per second. We got a velocity initial, we got a velocity final. It's a uniform acceleration. We're looking for that v average. Our velocity average, again, it's our velocity initial plus our velocity final divided by 2. Let's fill in what we know. Velocity average is our velocity initial in meters per second, 5.56, plus the 22.22, and we're going to divide that whole thing by 2 to get us a nice velocity average. And remember, once you get this average velocity, you can treat it like a constant velocity for these types of calculations. We have 13.9. We might as well have been told a car is going 13.9 meters per second, because that's all we need to do now. We go back to our equation, v equals d over t, our very first little kinematic equation. We're going to use that v average. 13.9 is equal to our distance traveled divided by our time interval, which was 10 seconds, multiply both sides by 10, distance traveled 139 meters. You can do this. V equals d over t can still be applied even if there's an acceleration, if that acceleration is uniform. I hope that this was helpful. Thank you very much for watching, and I'll be looking forward to seeing you next time.